last question is that a pair of fair dice are thrown, and they want you to complete the tree diagram. And so you have to think about probabilities and tree diagrams, but what's the chance that you get a 4 on the first die? And that's obviously 1 out of 6. So not a 4, it's 5 out of 6. And this is how we're making this a binomial problem, and the fact that we're still having only 2 outcomes and they are independent of each other when you roll the second dice, because it doesn't matter what happened on the first. And so we're getting a binomial problem has 2 choices, and each trial is independent of each other from the last. And so here we have filling in our tree diagram. And then when we look at question B, it's asking, so what's the event of exactly 1 4 occurs when the pair of dice is thrown? And we do need to look back at our tree diagram and find out where does 1 4 occur, and it occurs having a 4 and not a 4, or not a 4 and a 4, and we multiply going down the tree to find that we have 536, and the same again for the lower tree. And so combining these two gives us the final result. Calculate the probability of there being exactly 1 4. Well, we just found out that that is going to be 536 plus 536, 1036, which we can also simplify to 5/18. So that was really just using the tree diagram to calculate this probability. And then we look at part C and D, and they want to calculate the probability that the event occurs exactly 3 times in 5 throws. And so we are back to our binomial, that X will be the chance that the event occurs exactly 3 times. Again, E, this event E is the event that only 1 4 is rolled. And so that's what we're talking about. So I should actually, I can say that really this is the probability that E happens exactly 3 times. And so out of 5 throws, when it's happening 3 times, and we just found out probability of it occurring times the probability that it doesn't occur. And when we calculate that out, we get the answer of 0.118. And then part D, calculate the probability that the event occurs at least 3 times. So we want the probability that E occurs at greater than or equal to 3 times. And again, we will just write that out as a summation of start at 3, stop at 5, and we have the probability of E equaling 3, 4, or 5. We work that out on our calculator, and to 3 significant figures, it is 0.135 or 13.5%.